Okay, we are about to start with React Lecture 2 for the Toptal Academy. My name is Vicente, or you already know me from Lecture 1. So we're gonna wait a couple of minutes so people connect, and we're going to start. Okay, I hope you are all there. So let's get started with this second part of the React.js course. So today we're going to talk about tools because in the last lecture we saw how to work with React. We understood a little bit of the ECMAScript 6 syntax. And we saw that implemented using the service ES_next_bin. So that was all good, but let's see how we can have React working on our own environments, right? So in order to have React working, we're going to have to install and configure a couple of tools, which are in fact part of the complexity to getting started with React. Most of the people are coming from other JavaScript framework for single-page applications. They often love the simplicity of having just a couple of JavaScript files together, and then that's it. They have it working. With React, that's a little bit more complicated because you have to install and configure all of these tools, and that takes some time and usually requires to read a lot. So what we're going to see today is, first of all, Babel. We talked about it a little bit on the previous lecture, but today we're going to see it in all the configuration and stuff. Babel is the tool that will allow us to transform our new JSX syntax for simplifying these DOM library calls. Also brings with that the syntax for ES 2015, 2016, and 2017, plus a lot of plugins. And this is an important thing because, as we are going to see, we can add syntax on our own. Babel will be in charge of compiling all of that into ECMAScript 5, or we could say into a JavaScript that any browser can understand. After that, we're going to see ESLint, which is a pluggable linting tool, which allow us to have good practices, check programming styles, and it also will allow us to configure guidelines to have the same kind of code styles across all the code base for our project. So if we have several developers, which is most of the cases, creating an application, we don't have to deal with each other's programming styles. With this, we can force all of the programmers to have at least a similar programming style, which in languages as JavaScript, sometimes it's a plus because you can go too complicated for you have too many ways of doing just one thing. So this will help us a lot. Later, we're going to see Webpack, which is also a pluggable model bundler that will allow us to create these bundles or these packages of code and send them to the browser. It is a way to automate our builds, our compilation process, and it's not only restricted to JavaScript code, but it can also compile CSS from LESS, from SAS, from whatever language you want to use. It is also used for templates, images, and font. So we're barely touching the surface of what Webpack can do. And in the end, we're going to see the React Dev tools, the React developer tools, which are a new tab in the inspector for Chrome that allow us to inspect React applications and not only the DOM produced by React applications. And it's interesting because we can see the properties, the event handlers, and the state. So let's start with Babel. So why to transform or to compile JavaScript? It's not that we tend to say we love JavaScript because you don't have this compilation process. Just write your code and boom, it's running on the browser. Well, yes, but in order to use new syntax as JSX or new versions of the JavaScript language as ES6 or all these ES 2015, etc. Yeah, we have to do a compilation process in the middle in order to produce JavaScript that it's already working on most of the major browsers, because they are not implementing the new versions of the language as quickly as they should. And someone will say, okay, but why to compile JavaScript? Why to compile to JavaScript again? Well, this has been going for a long period of time. We can go far as the early 2000s, where we saw like 3 ages, 3 different eras on this 15 years period of time. I would say that the first period, the first age, it was called I hate JavaScript and I don't want to learn it. I just want to keep programming on my language. So the first tool that we saw compiling to JavaScript were tools like web forms from ASP.NET. They allowed you to create components using .NET languages, and then those were compiled into some sort of part on the JavaScript, on the client side with JavaScript, and some parts on the server side. They had this ugly page state. And it was super popular for enterprises, but it was not widespread in the mainstream. So it was like a limited technology. Later in 2006, Google came out with the Google Web Toolkit, which was based on Java. The idea is the same. I write my components in Java, and then part of them are compiled into JavaScript. It was super successful. It was a serious attempt. It was super popular, so even Google used that on a couple of their internal projects, and most of their internal projects, as a matter of fact. So that's like the end of that era, and then we have the new age, which it would be called like this part here, these 2 guys. It was like, okay, I learned, I call this age, I learned JavaScript, but I hate it. I still hate it. So how could I improve it? So the first attempt, the serious attempt that we saw in 2009 was CoffeeScript. It was a bunch of language improvement on JavaScript. It was like a superset of JavaScript, and it brings the fat arrow functions and a couple of other things that were super popular, reducing the amount of type to write a program, reducing the lines of code, always reducing the lines of code, reduce the amount of errors that you're going to write. So it was popular for that, but never went to be a production-ready product. Actually, a lot of companies implemented this on production, but it was not entirely recommended. Then we saw in October 2012 TypeScript. This was another serious attempt, in this case from the hands of Microsoft. And it was mainly to add type notation to JavaScript. You know that JavaScript have types, but they have dynamic types. So it's a discussion there if it's typeless or it's not. Yeah, well, it depends on the perspective. But yeah, we have types in JavaScript, but variables can have any type. So are like containers with multiple types. So that was a bit complicated for developing and for finding errors in the compilation time. And then, well, this type notation from TypeScript is super useful. And actually, in the same way that CoffeeScript was a big influence in ECMAScript 6, TypeScript is going to be a major influence in the versions of the language to come. In ECMAScript 7, well, it's almost, nobody call it ECMAScript 7 nowadays. They call it like ECMAScript 2017, because we don't really know if this type notation are going to be on one ear or the other. And then we have like this new era that we are living in right now, which is, well, okay, JavaScript turned to be, proved to be a robust language. So now we can start to compile from another languages to JavaScript. Then in August 2010, with the invention of Emscripten, sorry, it's a bit difficult to say, from Emscripten was the first low-level virtual machine compiler to JavaScript. So this bring a lot of C libraries compiled to JavaScript. They were not super optimal, but then suddenly you were counting with all the C library that you want in the JavaScript world. So it was really interesting. And also we have Sprima, which was the first, well, not the first, but one serious attempt for compiling JavaScript into JavaScript and transversing the AST with JavaScript itself. So now you can take a code from JavaScript and go inside of the syntax tree and manipulate the nodes as if you were manipulating nodes from the DOM. So it was pretty interesting. And actually, that allowed to create most of the tools that we're going to see today. Later, in March 2013, we saw the coming of ASM.js. ASM.js combined with Emscripten were a huge win for JavaScript, because ASM.js is nothing else than a JavaScript subset which has some restriction of what things you can use and what things you can't, in order to allow the optimization from the compiler, the optimizator from the compiler, to generate the blazing fast code to run on the machine. So that means if you just target ASM.js instead of the entire JavaScript language, your program is going to be super fast, almost like a native language for your platform. So if we combine ASM with Emscripten, we had C libraries running on a browser at super speed. We saw by this time the coming from, for example, the Unreal Engine running on a browser. It was like a huge success for that time. Finally, what we saw in October last year was WebAssembly, which is based on these ideas. So now JavaScript turned to be an assembly code for the language. So now JavaScript is almost like the target language of any other language. With WebAssembly, now you're going to be able to send a binary format that it's going to be parsed through JavaScript, compilers convert to ASM.js, and run with compiler optimizations close to the machine super fast. So we have been compiling different kinds of code to JavaScript for at least 15 years in the world. So it's interesting that we had, for example, I leave you here from Jeremy Askinus the link for all the list of languages that compiles to JavaScript. It's pretty interesting because there are like thousands. So yeah, we have been compiling to JavaScript for a very long time. So Bubble does this, but it's not the only one, but it's the best. Well, at least it's the best for now. We can see in the comparison table for the compatibility of different engines for ECMAScript 6. I leave the link here. You can see that we have Traceur, Babel plus Core.js, Closure, TypeScript plus Core.js, and ES6 shims. And currently, Babel is like 74%. These percentages change every day, so just keep an eye on this table. It's really interesting. So I could say that Babel is the best one for now. Maybe in the future we're gonna see some improvement. Okay, so that's super cool. Now let's take a look at how to use it. So I'm assuming that you're already familiar with Node and NPM. So we're going to skip that part and go directly to how to install Babel. To install Babel, we're going to install the Babel client interface, command line interface, sorry. And we're going to install it with this save dev in order to put it on our package JSON, and not globally. I know most of you are, if you already read the Babel installation process, some places say that you have to install it globally, and somewhere it says that you shouldn't. The reality is that Babel has just changed from version 5 to version 6, and it was like a major change. So now they realize that targeting to global is not always good. So it's much better if you keep your Babel command line interface in your project, so you can have several projects with different versions of Babel. So let's see how to do that. Never mind that. We're going to install with npm install save dev Babel. So while I'm installing this, I'm going to show you my package JSON is just this simple file here. Here, npm is going to add, when it's finished, it's going to add the dev dependencies with the Babel client command line interface version and stuff. And I only have one source folder with an index, which make it bigger. Perfect. With only this file, we're going to try to, this is using let instead of var. I'm exporting as if we're a model, what I'm creating. I'm creating a function here. Using here 5 functions. So mainly what we want to see if it's change these 5 functions into an ECMAScript 5 function. So it ended, yeah, perfectly. Okay, now we can see here in the package JSON that we have the dev dependencies. Here we say Babel command line interface 665. So how do we use it? Okay, well, to use it, it's super simple. We just type Babel and the file that we want to compile. And if we do that, it's going to output the compiled version directly in the command line. So we can specify an output file, or we can just say -o and send the compile target file, or we can just compile directories in the same way. So let's give it a try. If we say here Babel source index, yes, let's say the entire directory, the dist. So what's going to happen? Babel is not found. And why it happened? Because we didn't install it globally. You know, if you install it globally, npm, it's going to put the binary in your path, so you're going to have visibility for your Babel. So this is not the case. So we have to go to the node models .bin/Babel, and now we can do source the test. Perfect. So here you can see, I'm gonna make this a bit bigger, that it says it was compiled. So now let's take a look at this.index. But it looks pretty similar. It's actually the same thing. It didn't work. Why did it work? Well, first, it didn't work because of this, the Babel, the non-global thing that I just showed you. But the most important thing is that Babel does nothing out of the box. It relies on plugins and presets to do anything. So if we want to compile from ECMAScript 2015 to ECMAScript 5, we need a plugin to do that. In this case, it's going to be a preset. But in order to configure this plugin and presets, we need some configuration. So the configuration file for Babel, it's going to be a simple .babelrc file that we are going to put on the main directory of our project. And it's just going to be a JSON file containing these two keys, presets, and plugins with empty arrays. So we're going to create it here. Let's say .babelrc. Presets. Compliance, perfect. And oops, in order to compile from ECMAScript 6, ECMAScript 2015 to ECMAScript 5, we need to install a preset, which is a group of plugins for Babel to compile that. So we're going to do that. Let's say npm install save dev Babel preset yes 2015. Okay, while we are on that, we have to also add the preset to the configuration file in order to find it and to make it work. So as you can see here, the package JSON now it's also depending on the Babel presets 2015. So let's add it here on presets. Yes. So now it's supposed to work. Let's see. Now let's check the distribution. There you see. Now it put it the strict mode. It is defining a property because it is a model that has some exports. And it actually, this is the important part that I want you to see. It changed it from factor function to an ES5 function. So now we are compiling with Babel. So that's it, mainly for Babel, compiling from ES 2016 and 2015, sorry. And also, if we are going to use JSX, which we are, you can install the Babel preset for React, which is simple babel-preset-react, and add it to the Babel RC configuration there, and it's going to allow you to use JSX. We're going to see this later, so don't worry. Now, there is also an important thing that not all of the features that were planned for ECMAScript 6 are already in the ES 2015 standard, because all the features are going through stages, right? So there are 5 stages, which we can consider that the last one is when it's part of the standard, and they are named from 0 to 4. So if a feature is in the 4th stage, it's part of the standard. It could be ES 2016, 2017, etc. But while they are in the process to be a proposal to a candidate, to draft a candidate to be in the standard, they go through these stages. And Babel also provides presets with all the features that are in these stages. This is super fun to use because you can test new functionality that it's going to be in the future in the standard, but it is not yet accepted in the standard. So they are going to strawman, to proposal, to draft, to candidate. You can use them, but please use this with extreme caution because they are not entirely approved. So let's see what would happen if you want to use the presets from the stage 2. There are going to be a couple of plugins that are going to be installed. Now you're going to have more syntax or more APIs that you can use on your language. And just add them to the preset as a stage 2. Now, every stage preset has a dependency on the previous one. So that means if I want to install the plugins that are in the draft stage with the preset stage 2, I'm going to also install all of the plugins that are in the preset 3, right? So the same thing is going to happen. If I want to the stage 0, then I'm going to install the stage 1, stage 2, and stage 3, and whatever. So keep that in mind. To see the content, actually, this is a good one because Babel has really good documentation about what a stage preset means. In this case, for example, in stage 2, we can see that it has 2 plugins, which are syntax trailing function commas and transform object rest spread. I just wanted to show you this one because we're going to use transform object rest spread operator in the future. So you are alerted that it's not in the standard, it's in the stage 2. And as you can see here, this stage 2 consists of only 2 plugins. And you can see also the list of plugins from Babel. Of course, you can find plugins out there in the internet, but this is the entire list of the plugins that Babel is providing. So if you want to add some particular syntax to your language, you can grab one from here and install it there. So there is a difference between adding new syntax to a language and adding new APIs. When you're adding new syntax, it's just about compiling the new syntax to the old syntax. But if you're adding new APIs, as for example, array.from, you're going to have to provide a polyfill, because what would happen if the environment where you're running your target code doesn't have this a new API implemented? So Babel relies on 2 polyfills, which are core.js and regenerator. Regenerator is from framework for this generator thing that I told you. And both of them are unified into Babel polyfill. So in order to provide that, you're going to have to install Babel polyfill and import it on every file that is using the polyfill. So let's take a look at that. And first, I want to bring your attention here. I'm using save and not save dev because Babel polyfill, it's going to actually be transmitted to the client when I'm using it. So let's see. I have a different example here for that. Close this. So let's see. Here I have just an array that is created from a class that is employees. We can see here employee is a person, and here there's a person. Okay, so you got it. That person just can't sleep. Yes, I hope so. And an employee can work. Sure, why not? And then if we are going to create a couple, we're going to use the array from method that is a new API for array in ES6 that will need to be provided by the polyfill. We're going to generate 10 employees and make them work or sleep in consecutive order. Okay. So in order to have that, I already have the command line interface and Babel installed on this project, and Babel RC already with the preset ES 2016. So let's go there. See, we're going to install the polyfill, npm install Babel polyfill. Save. So as I'm saying save and not save dev, instead of being in dev dependencies, there it is. It is in dependencies directly. So if we take a look at the code, I also need to import from without the from. Forgetting this syntax. Bubble polyfill. Perfect. There it is. Now, if we compile here, I'm just forgetting to tell you something. Okay, yeah. If you are going to be compiling with Babel, or if you're going to be doing any task that has some configuration on your command line, you can create here in the package.json, in the script key, you can create several keys here with the kind of the command that you're running. In this case, I'm just running Babel src with the destiny for the distribution directory. And the interesting thing here is, as you can see here, I'm just calling Babel as if it were installed globally. But if it's not, it's going to go automatically to the node models .bin directory and search for it. So it's much more clean. And instead of doing this node models /bin, I can just say npm run build. Going to run my build from Babel, and now let's see what the end of it. Okay, perfect. Now it is calling Babel polyfill, so it's going to be required there. Now I can ensure that the array.from is going to be present because the Babel polyfill is going to polyfill it if it's not there. So let's run it. Can say node list / index. Yes. And you can see we have our employees sleeping and working. That's perfect. Okay. So in the same way, we have runtime, which are helper methods that, for example, for creating classes and extending classes, Babel has these helper functions that are checking and doing stuff under the hood. So we have to, we're going to be, show you, we're going to be, for example, for person, we are including this create class called check, functions there, and for employees, we're including them as well. So yeah, this is replicating the same code in different parts. So it would be much better if instead of replicating all these helper functions for every file that is using a particular feature from the language, we can just put that runtime in one part and then depend on it. So in order to do that, we're going to install another plugin, which is Babel plugin transform runtime. Let's install it. npm install dev. I will take a look at that. I'm using dev because it's a dev dependency. I'm not going to use the transform runtime on the client, but I'm going to use the runtime because I'm going to depend on that. So it's Babel plugin transform. Pretty quick. Now npm install save Babel runtime. Okay. So now that we have that, we have to go to our Babel RC and say that we are going to use the transform runtime plugin. See that I don't have to specify the entire name of the model, just because Babel already understands that it's going to be Babel's dash plugin. And now we're going to run our npm run build. And there it is on our distribution. Now we are requiring these functions for get prototype of class called check. And those stuff are now set as a dependency instead of being created on every single file that uses that kind of features. So if we're running it again, we have our employees working and sleeping again. So that's perfect. Okay. It was cool, huh? Babel is an interesting tool. I encourage you to take a look at the documentation because there is an important part here on the handbook. You're going to see that you can go through the user handbook or the plugin handbook and create your own plugin for Babel, which means that you can add whatever feature you want to the language, to ECMAScript 2015. And why not? Later, you can just present it to the Technical Committee 39 of the ECMA and see if they accept it. And maybe someday you will be included on these stages. I'm going to do it. So pretty soon we're going to have a Picante script or something like that. Yeah, and I hope you use it. Okay, so that's it for now. That's Babel. Now let's go to ESLint, this pluggable linting for best practices in programming style. So ESLint, in the same as the Babel, is not the first guy here that comes with the linting idea. The first one was JSLint from Douglas Crockford. The idea was about trying to restrict the language in order not to use the bad parts. And that quickly started to be a broad used application tool in this case. And then it came JSHint with almost the same uses as JSLint, but with more rules and that kind of stuff that you can just configure to use it or not. And then we have JavaScript code styles. Those three are pretty good, but ESLint is by far the best because ESLint in ESLint is pluggable linting. So now every single rule is a plugin on ESLint. So how do we install it? This is super easy. It's just npm install -g ESLint, and yay, this time is global. So let's go ahead and install it. I already have it globally, but it is also recommended to install it locally in your project, because in that way you're going to alert your users, your developers, that you are using ESLint, and they should configure it as well. So I'm going to install it locally, npm install dev ESLint. There we are. And how do you configure it? It's super easy. You just have to go and type ESLint -- init, and it's going to create our ESLint RC in the same way as our Babel RC for us. So let's take a look at that. I'm going to do ESLint init. In this case, I don't have to put the / node models stuff because it's already installed global. So I have this here, a couple of questions for defining my style. So I could use answer a question for defining your style, or use popular style guides, or inspect our JavaScript files. So for now, we're going to just answer a couple of questions. We are going to use ECMAScript 6, yes. We're going to use ECMAScript 6 models, yes. Where our code is going to run. For now, it's going to run on Node and not in the browser. We're going to use TSX, yes, for sure. Well, actually, no, because we are not in the browser. What style of indentation do you use? Spaces, and which kind of quotes you want on your strings, single quotes, and endings, Unix. And do you require semicolons? Yes, of course. which format you prefer. This is interesting because ESLint allows you to have your configuration files in all these 3 different formats. So that's it. And now let's see what ESLint did for us. Now we have a .eslint.rc.json file with the configuration for our project. So it's much more easy than Babel. It just creates the ESLint RC for us, so it's much more simple. So how do we use it? Just run ESLint, the directory or the file that you want to see. So let's give it a try. Okay, so we can see here the list of the errors that we have there. And if you take a look at there, it's more about indentation and expected console, no console statement, and that kinds of stuff. So it's super easy. And that's it. Well, it could be, but it's not, because actually ESLint has a lot of different things that we are going to use in order to have the most power to use this powerful tool. We have 2 ways of configuring ESLint. First one will be by comments. You can just enable or disable different rules in your code by a comment with ESLint and the name of the rule and value. We're going to see what this value are. This is not recommended. It is embedded directly on the file, so it is just by file. And the other way is using the configuration file, the one that we are using right now. We have this 3 format, and also we can use a key ESLint config in our package.json. It is extendable and it has cascading and hierarchy. We're going to see what is that. So let's see. In our files, we can configure the parser options, the parser itself. We can set in which environment it's going to run. We can enable or disable global variables. And of course, we can configure all the rules that we want or need. We can extend our configuration from another configuration file. This is really interesting to share configuration files between projects. And we can have also plugins, and that's also interesting. We're going to see why. So first, parser options, we can specify with ECMA version we are going to use. By default is using 5. So if you're going to use any ECMAScript 6 feature, you have to specify it. The source type could be script or model. In case of a script, it's not going to allow any of the model syntax in ES6, like import and export and that stuff. And it's also in model, it's going to specify the strict mode as well. And the ECMAScript features, if you are going to use TSX, you have to enable it. And as I told you before, that we are going to use the object REST spread operator. It is so widely used that ECMAScript ESLint has a special option to enable that. So let's see. In our configuration here, we can specify the model. We can say ECMA version to 6. So it's there, and not much about that. So the parser, we can actually specify which parser is going to use ESLint. ESLint by default uses the Spree, which is a parser created by the guys from ESLint, which is Nicholas Sakas, a really great developer. And also it could have a Sprema as the parser for JavaScript, or Babel ESLint, which is like this wrapper around Babel in order to make it work with Sprema compatible things. So what a parser must contain in order to be used with ESLint, it must be an NPM model installed locally. It must be a Sprema compatible interface. It should have a parse method, and it has to produce an EST compatible with the Sprema. So to install Babel ESLint, we are going to just have to do that. So let's go npm install Save it. And we're going to say use the parser see again. And we can now specify here the parser Babel ESLint. And now, because if we are enabling, you would say, why do I have to specify Babel as the parser for ESLint if I already say that I'm going to use ECMAScript 6? Well, because nobody knows what ECMAScript 6 means. And with Babel, it's even worse. ECMAScript 6 could mean ECMAScript 2015, 2016, 2016, and everything from the stage 2. So ESLint doesn't really know. So if you're creating this modified kind of language for your own with your Babel plugins, and you cannot specify that into ESLint. You cannot say, hey, I have this and this and this features enabled for my language. Only, as I showed you, the object display operator. But all the other features, you are going to configure them in Babel. So if you tell ESLint to use Babel, then ESLint will know which are the allowed features that you're going to use. So in that case, you're going to ESLint again, and it breaks. Awesome. And it breaks because this is interesting, because it is, I'm using here the global version, and I installed Babel ESLint locally. If you take a look at the directories here, I'm using it, I'm running ESLint from my Node installation instead from the local installation, and I don't have Babel ESLint installed globally, so I'm going to run it from Node models in /ESLint, and it runs. There it is. Okay, so the environment, ESLint allow us to have several environments. Actually, the list is much bigger, but these are like the most important. So you can enable your script for all of this environment. And what this is going to do is just going to enable some global variables common in that kind of environments. If that's not enough, you can declare your own global variables using the globals. And now here for the fun part, you can go ahead and in the key rules, you can specify for each rule's name one of these 3 values. Off or 0, which means the rule won't care. 1 or 1, which is just going to be an alert, but it's not going to stop the execution of ESLint. So it's not going to be like some error happened. Or just an error, which means if it's level 2, this rule must be approved. If not, there is an error and ESLint stops and returns an error code of 1. So how do you specify it in your JSON? Just like this. And there is also this kind of, some rules might accept some configuration. So you have to send it in an array where the first element in the array is the level of the rule itself. And then you can have the configuration for example, in this case, requiring double quotes for the term. You can see the entire list of rules available for ESLint in this ESLint rules page. There are a lot. And if you take a look at this page, you're going to see that some of the rules have this icon, which means that you can actually transform your code and fix the problem that it's bothering the rule. So if you run it like this, there's fix. then it's going to fix the errors. As you see there, there was a lot of problem with the indentation in several of my files, and now there's only problem with the console statement. So ESLint could help us to automatically modify our files and be compliant with our code styles. Now, for the cascading and hierarchy, this is how ESLint is going to search for the configuration file where you're running. You have your project directory, and you have your main ESLint RC file with all your configuration there. But you can have different configuration for the server, for example, where you're going to set the environment to Node. And for your client, you're going to set your environment to browsers. And this kind of stuff. You can modify your configuration depending on each directory, but it doesn't end in in the root of your project. Actually, ESLint is going to search on the parent directory until the root of your file system. So if you want to work with a set of rules on all of your project, you can just put an ESLint RC in the main directory for your development, and you can be sure that ESLint will be always reading that configuration file, and all of your projects are going to be following that code guidelines. If you don't want your project to be affected by the configuration files in parent directories, you have to set the root key to true. Now, if you want, you can extend from another configuration file. So, for example, you can distribute your configuration files as npm models, and then anyone can just install the configuration file and extend from it, which is actually what some of the plugins are. But for example, we have here this other plugin for React, which comes for rules that help you to understand JSX, and things that ESLint doesn't do by its own. And also comes with recommended guidelines, which is going to help us to understand React with ESLint. And also, I forgot to tell you this, that most of the editors have a package that you can install and see the errors from ESLint right in your editor there. So here I can see this index problem, indentation problem, and the console statement. So it's an interesting add-on for your editor, so you don't have to wait until you run ESLint from your command line. As an anecdote, you can use the configuration file from Airbnb, and these guys are going for the using trailing commas on your configuration, because on your in that way on your Git commits, then you're not going to be modifying 2 lines. You're just going to be modifying 1 line, the one what you're actually adding, and not the one before, just for adding the comma, and it's much more simple to read the commits. Yes, for that. Okay, so it was a good one, right? So use ESLint. It will help you to improve the quality of your code and have the same code style across an entire team of developers. Now, this is a really big one, and we're running out of time. So we're going to be very surface of what Webpack can do, but it is a really interesting thing. So again, Webpack is not the first model bundler. We have React.js, Browserify, GSPM. All of them are pretty good at what they're doing, but Webpack is not just a model bundler. It does a lot of things more. So it has AMD, asynchronous model definition. Remember that from React.js that we talked in the last lecture. And also supports CommonJS, the typical required that you use for models in Node, and also supports ECMAScript 6 models. So this is cool because now we can use any of these 3 syntax. It also has chunks of generated files instead of model bundlers. Well, before model bundlers, you have just one request for each model when you were retrieving from the client one file for model. And then, for example, with React.js, there was this first tendency to create a big bundle with all your libraries and all your code, everything in just one request. This was not good. It was not performant, and you were downloading all of your application, even if you're using it or not, all the parts of your application, if you're using it or not. So they decided to create these chunks where you can define which parts of your application will be in these chunks of code. So you can just download the minimum required to boot your application on the client side, and then as the user is navigating, request more chunks for the rest of the application. And why only work with JavaScript? Webpack also allow us to compile CSS and do a lot of stuff with images and stuff. So how do we install it? Yes, it's again, globally, you can just install it with npm the Webpack, but it's strongly recommended to save it on your developer dependencies as well. And how it works. So let's give it a try. You're going to see here. Okay, perfect. So here it is. How does it work? It just you can just indicate the main directory, the main file that you're going to use, and what the entry point of your application, and where do you want the output to be. So let's see. For this case, I'm using the final application that we had from the last lecture. Which was the application with the clickable and items. So clickable is just this React component that handles the click. Now it is written as a model in ECMAScript 6, and we have the item also as a model, and the application is actually importing them from those files. And the index is just importing the application and rendering with the DOM renderer. So that's pretty much it. If we have Webpack installed, which I have, I'm going to run Webpack. So C index. And in this case, my destination directory is public/JS bundle. Yes. So it doesn't work and it fails. Why does it fail? Because as you can see here, it's an unexpected token. You might need an appropriate loader for handling this file type. Because Webpack itself just understands ECMAScript 5. So we need a way to tell Webpack to compile through Babel ECMAScript 6, turn it into ECMAScript 5, and then package it in everything in the bundle directory. How do we do that? Configuring Babel inside of Webpack. So in order to have this, we need to install the Babel loader for Webpack and the Babel core. So what we're going to do is we're going to create a Webpack config file where we're going to add this part here. So let's give it a try. Going to create a Webpack config JSON, that's JavaScript, and we're going to do model and here we need for the configuration. I'm going to take a look at this very quick. The configuration here. Sorry, samples always fails. There we go. So now what we have here is the Webpack config. There it is. This is a config file that it's going to be it's going to run in Node. So we have to specify the entry point, which before we were specifying by the command line, and the output, which receives these two steps. The path is the directory, and the file name it's going to be in public.js.bundle / bundle. And now we specify the loaders for the models, and everything that is JavaScript, it's going to go through the Babel loader that we recently installed. So now let's give it a try again. If we have a Webpack config file, we don't need to specify anything on the command line. So just running Webpack should do the trick. Takes a bit, and that's it. It is compiling. So now, in order to see our application, I'm going to run here and same directory and HTTP server. And as we can see, we have here our application that before, in order to have it running, we had it in ES-Next bin. Now we have it on our own environment. That was for installing the Babel loader in order to allow Webpack to understand how to use it. So now Webpack has this interesting configs in the command line that you can have here. Instead of just running Webpack, we're going to say progress. So now instead of waiting all the time, we can see what it's doing. And even better, we can say progress and watch. So every time that I modify one of my files, Webpack is going to be watching. And if I modify the source code, then it's going to, let's give it a try. It's going to say, if I say, I don't know, Bernie can add Robert. Save. You go here, there, it's compiling again, and then that's compiling, and there it is. I can just reload, and I'm going to see some Robert, maybe. Okay. So I think that I'm not seeing it because here I have to. There it is. Now we can see some Roberts there. Okay, perfect. So that's what Webpack can do for us. And what is more important, when we are going to debug our application, here we can see another source that it's called Webpack : / where we can see our source code. So this is using source map. So we can see all of our, I don't know if you can see it. This is too small. Bigger. There it is. So let's inspect a bit more. And there it is. So now I can inspect my application, even if my browser is running the ECMAScript 5 code, I can see the ECMAScript 6 from where that code came from. See? And if I open here the bundle, I can see the ECMAScript compiled code. Now, sometimes you're going to face a problem that debugging this code, it's not super easy because the code that is running is actually the ECMAScript 5 version. So that's why you can have here in this Webpack config file, you can change the dev tools from source map to eval. If you set it as eval, let me stop Webpack here and do it again. still binding. There it is. Okay. Now, if you set it as a val, what you're going to see in your Webpack folder is going to be the ECMAScript 5 version generated by Webpack. So now you're going to be able to debug this much more easily. But that's not it. Webpack have also plugins, which are super interesting. And I encourage you to take a look at them. You can have plugins to loaders, for example, for less or SAS in CSS to modify, cut, and change the size of images for a lot of things. But one of which is quite interesting for me is this Webpack notifier, which is super easy to configure. It just requires to require the plugin here on the top in the Webpack config file, and then on the plugins array, you can just instantiate. It has some configuration, and I found that this always notify is the best for me. And it allows you to, for example, if you're going to change something on your application, let's see if I'm breaking this import, and it's going to run, and it says that it doesn't have the file there, and it's going to trigger a notification. But as I'm in a presentation right now, I have the do not disturb, and that was why it's not fine. Let's give it a try again. Is save. And you will be able to see, there it is, notification Webpack, there is an error, and if I fix it here and then save it again, I'm going to see Webpack failed successful. See, so it's a small thing, but it helps sometimes. Okay. Finally, I'm just finishing, so don't worry. The React Developer Tools. This React Developer Tools is a plugin for Chrome. You just search React Developer Tools, and you're going to be redirected automatically. And it allows us to inspect our elements in React. And we are going to be able to see the properties, the state, and the events, and it's everything on a tab. So we have here our easy, our simple application in React, and we can see that we have another tab here called React. And this is the React inspector, and we can see here the elements, the application. We have the clickable element here. So you can also see the node, the DOM generated by those elements. The elements here, the items, you can inspect the content, the property as it was sent. And if we inspect this element here, for example, we can see the property content is an object with age and name. For example, for clickable, you can see that the handle click property was bound to the add person function from the application. And in the application, you can actually see the state as well, which is this data array and that stuff. So it's super easy to install and to have it. I didn't find it so useful for now, but well, it is at least one tool more that we can use for React development. So that's it. I think that we can wrap it saying that the key word for this lecture was tooling and plugins. So this part of React is the most difficult one. Even the guys from React, I'm trying to find a way to give you this ES Next Bin environment, so you can just download something and start writing React applications without having to know and understand all of these tools. But it's super interesting to know them. And in the future, we're going to see these React starter projects, which are configuring most of this application for us. For example, you can see here Babel 6, ES6 as well, and a couple of other things, Redux, router, and stuff that we're going to see in further lectures. So I hope you really like it, and I will be waiting for you next Tuesday. See you guys.